Okay, now let's look at this question. The question says that let R be the relation on the set of positive integers such that A is with relation to B if and only if A and B are distinct and have a common divisor other than 1. Okay, so what does this it mean? It means that something like when we are talking about R2 and 3 related, so they are not related because they are saying that they should be distinct. So it means that if 2 and 2 we are talking about, obviously they are not related because they are same, and even if they are distinct, they should have a common divisor other than 1. Here other than 1 there is no common divisor, that's why again they 2 and 3 are not in a relation. But what about 2 and let's say 6? What about this? So here they are in relation. Why? Because they are distinct, this condition is satisfied. They also have a common divisor other than 1. What is that common divisor? That common divisor is 2. So 2 divides 2 also, 2 divides 6 also. So other than 1 they have a common divisor, and that's why both these conditions are satisfied, and that's why 2 and 6 are in relation, right? Now using this definition, they have given 4 options, and we have to see that what is true and what is not true. They are talking about 3 things: symmetricity, reflexivity, and transitivity. So first of all, in general, we'll try to figure out that whether such a relation is symmetric, transitive, and reflexive or not, and then we'll come back to the options. So let's talk about firstly reflexive. So here only I have said again A and A, they will never be in relation. Why? Because they have to be distinct. So definitely it is, we can say that it is not reflexive, that is for sure. Okay, this is done. After that let's understand about symmetric. So symmetric means let's say A and B are in relation, and does it imply that B is in relation with A? And that is true. Why? Because see, if A is in relation to B, it means that A and B are distinct. So here also B and A will be distinct, and they have a common divisor other than 1. If A and B are having common divisor other than 1, then B and A also have common divisor other than 1, obviously. So we can say that it is symmetric. Okay, so symmetric, it is symmetric but not reflexive. What about transitivity? Now here we are talking about that if A is in relation to B, okay, and B is in relation to C, then can we say something about that whether A is in relation with C or not? If yes, then it is a transitive relation, otherwise it is not. So rather than trying to prove this, actually this is not the case, we cannot say this, and it is in order to say that, it is just enough to have a counter example such that this and this holds, and still this is not the case. So definitely we will know that this does not hold. I'll just give you an example. So we can clearly know that 2 and 6 are in relation because they have a common factor 2, right? Similarly, we also have 6 and 3 in relation, right? Because 3 is a common divisor of both of them. So 2 is in relation with 6, 6 is in relation with 3. Is it the case that 2 is in relation with 3? Which is not the case. Why? Because 2 and 3 are distinct, but they don't have anything in common, no common divisor, right? So this is not the case, and that's why I cannot say this. Okay, so what is the final conclusion? The conclusion is that it is not transitive. Okay, so we came to know that it is symmetric, but it is not reflexive and not transitive. Now let's see the options. So we're talking about R is symmetric. So so the answer is, correctly we can say that symmetric but not reflexive and not transitive, right? So the answer is basically D. R is symmetric but not reflexive and not transitive. Okay, so the answer is D.